Let's talk a few moments about TCP and UDP ports and their relationship to applications and services. Network applications and network services. Any service such as DNS, DHCP, the web service, simple mail transfer protocol, etc. that communicates over the network has to have a way of identifying which packets received by the host computer the service needs to process. This is accomplished using TCP and UDP port numbers, typically destination port numbers. And remember here, these ports are not real. They're done in software, so don't be looking around on the back of your computer to try to find these. So each network service or application listens on a TCP or UDP port, sometimes both. DNS, for example, listens on TCP port 53 and UDP port 53, excuse me. So how does this work? When the computer receives a packet, it checks the destination TCP and UDP port, and then checks to see if there is a service or application listening on that port. We also say that the port is open. So this is two ways of looking at this. A port can either be open or a port can be listening. And this simply means that there's an application that has been installed, a service that's been installed, that's told the operating system that if a packet comes in with a destination port that matches that, send it to the application. So if we get a match, the packet is directed to the application. Let's draw a little picture here. We'll let this be our computer, and I'm going to put the layers over here of TCP/IP. Down here at the bottom we have the network layer, and then above this we have the internet layer, and the transport layer. And finally, up above we have the application layer. So what we're going to have here is at the transport layer, among other things, we're going to have ports. We can call these TCP ports, TCP, and we can have some UDP ports over here. Now I don't have room here to put all 65,536, so I'm going to pick out a few off the top of my head. So if we get a packet in here, let's suppose the packet is has a TCP destination of port 80. It's going to come up through the and TCP/IP part of the network is physical and part of it is up here. So it's going to come up through the stack, and of course at the internet layer it's going to be the internet here is going to be stripped off, and the TCP/IP stack is going to discover that the embedded protocol is TCP. At the transport layer, the TCP header is going to be read, and it's going to be discovered that this packet goes to port 80. Now, above this, at the application layer, we've got a web service here. So the transport layer is going to send this on up to the World Wide Web service. If we've got another packet coming in here, UDP 53, same thing's going to happen. It's going to pass up through the through the layers. When it gets to the transport layer is going to realize it's destined for port 53, and it's going to be passed on up to the DNS service. So here's how this works. You can again imagine that these ports aren't real. They are written in software. In essence, they are a table that is used by the operating system and the TCP/IP stack to make the connection between where the destination port, TCP port or UDP port is, and which application is listening on that machine to those ports. So this is how this works. In some cases, your application uses the same TCP and UDP port. If you have certain types of DNS requests, they come in on TCP, so it could actually go over here because it's a TCP port, and then be routed back to the DNS service. So that's another example of what can happen here. So why are we talking about this? This is a very important slide. I want you to really think about this. Any network service or application is a potential source of vulnerabilities. This is because services and applications are written in software. Programmers make mistakes, and these mistakes are vulnerabilities. Now, attackers, and you can put an ER on this, attackers look for and try to exploit these vulnerabilities across the network. And if they're successful, they can often gain control of the computer this way. So the third bullet, we want to minimize the number of computers and open ports exposed to the network by using a packet filtering router and a firewall. Now there's some other things we can do, and we'll talk about them later, but I want you to get this concept down between the relationship between vulnerabilities and exploits, and some of the things you can do to basically limit your exposure to the exploits. Now, in the interest of being efficient with their attacks, attackers don't want to just indiscriminately attack every computer and check every port with the list of exploits they have at their disposal. They want to be a little more scientific about this, if you will. So what they want to do is they want to tell if a port is open. Now, if a port is open, that's an indication that there's an application or service listening on that port. And once an attacker determines this, they can oftentimes figure out what version of the application or service is running, and then they can go look, typically do a search on the internet to see if there's a known vulnerability. If there's a known vulnerability, there's probably already been an exploit written that the attacker can simply use to try to take control of this computer. So, attackers are very interested in finding open ports. So to determine if a port is open, the attacker tries to connect to it. I can add here using the three-way handshake. That's HAKE. A connection attempt starts with the attacker sending a send packet. If the port is open, the computer will respond by sending back a SYN-ACK packet. Now at this point, the hacker knows that that port is open. Really, the attacker doesn't have to do anything else at this point, since they already know the port is open and that there's a probability for an attack. They can go off looking for exploits, and they don't even have to worry about the final step of the three-way handshake. So if the attacker receives back a SYN-ACK packet, this tells the attacker that the port is open or listening. So now the attacker has some information about one of our computers. You want to try at all costs to limit the amount of information attackers get a hold of about your computers and what's running on your computers, because knowledge is power. Now, the other case, what if the port is closed? If the port's closed, we also say it's not listening, which means no application or service installed that is installed that uses that port. The computer or the TCP/IP stack will respond with a reset acknowledgement, and RST is the abbreviation for reset. This reset act tells the attacker not to waste his or her time on that service or application on that particular computer. So now the attacker is going to go on to a different computer or different port on this computer. So we've got two situations. The attacker sends a SYN packet, and the attacker's looking at what's coming back. One of two things: either a SYN-ACK packet or a reset ACK packet. And this is normal operation. We'll see a little later on some things we can do about this. So let me show you a simple drawing about the open and closed port response. Attacker is going to be over here, and we're going to have an open port here. The attacker is going to send over a packet with the SYN flag set. If we do have an open port here, what's going to go back to the attacker is a SYN-ACK packet, the second part of the three-way handshake. At this point, that's all the attacker really needs to know. Some tools are nice enough to finish the final part of the three-way handshake. Some don't. Some just leave it out. So what if we have a closed port? Attacker sends across a SYN packet, and what he's going to get back is a reset ACK packet. And again, he's learned something. He's learned that there's a really good chance that there's no service listening on that port. And you'll see later on, one of the things we can do here is put a firewall in between this and even cut down on some of the information that he or she, the attacker, is going to get. So we've already been talking about port scanning. Let's talk about it some more. Numerous tools, by tools I mean utilities that run on your computer, exist to help attackers scan all the ports on a computer and see which of these ports are open. These are called port scanners, obviously. There's some pretty good ones out there. There's one called Nmap. I like one called SuperScan version 3. There's a version 4. I like version 3 better. I like Nmap. The problem with Nmap is Service Pack 2 for XP kind of broke it. So you may have limited luck getting it to work properly on an XP machine. So once an attacker determines the port is open, he or she can search the web for known vulnerabilities for that service or application. I've given you examples of several services. Applications that could run on, be network aware, could be, for example, a Microsoft SQL database or an Oracle database. These are all, these would be applications that could be listening on a port. So the attacker would search the web, or maybe search his own personal database, for known vulnerabilities for that service or application. And if there is a vulnerability that's been announced, there's probably an exploit already developed. And there's probably also a patch developed. Now, the problem is, oftentimes people, don't patch their computers. We'll get to that in a moment. A few common ports and services. TCP ports 20 and 21 are used by the FTP service. 22 is used for secure shell. This is mainly you find this most of the time on Linux and Unix boxes. You can find it on Windows, and it's a good way of doing things. Telnet, don't use Telnet if you don't have to. It has some serious security issues, one of which is the fact that excuse me, it's late. One of the big problems it has is that your username and password are sent clear text across the network. TCP/25 is a simple mail transport service. If you're going to have a mail server, it's going to be listening on 25. UDP/53 is DNS, as is TCP/53. Most of the traffic is on UDP/53. TCP/80 is the World Wide Web Service, and there's many, many more of these. Microsoft Networking has several. There's just a bunch of these. There's actually a whole list I'll send you some links to. So the important thing here is, from our standpoint in network defense, we need to know what applications need to be available from the internet, and what ports these applications are listening on, because we're going to have to open up holes in our router and our firewall to let the traffic in. So, what can we do about the attackers scan error ports, looking for listening services and applications, and then trying to find vulnerabilities and exploits in these applications and services? First thing is, don't install any service or application you don't need. Don't do it. Now, I remember the good old days. A lot of times when you're installing an operating system, you would say, well, let's go on and put that on there because we might need it sometime. That's not a good plan anymore. You want to carefully plan what you need running on a machine and turn everything else off. Don't even install it if you can if you don't have to. You want to run bare minimum number of services and applications. It's just more secure. Things you do have to run, you want to make sure you keep your applications and services patched. I mentioned a while ago that a lot of times attackers will exploit vulnerabilities for which, well, we know about the vulnerabilities, and a lot of times the software vendors have already released a patch. So it's nobody's fault but yours that you haven't installed the patch. Finally, use packet filtering at your border router and a firewall to limit the packets coming into and going out of your network to those absolutely necessary and no more. So this is what we're going to look into in much more detail in this class, is this concept of limiting what goes into and what comes out of your network. Now, there is a problem with this. Some things you just can't hide. For example, if you're a company and have a web server, somewhere this web server has to be made accessible to the internet. Otherwise, no one could serve to the web server and use it for what you bought it for. Serve up information about your company. So, some things we can't hide. Other things are used mainly internally inside your network, or maybe exclusively inside your network. We can certainly hide those from the internet. So we'll be looking at applications and services, the ports they're listing on, and we'll also be deciding what we can limit access to from the internet and what we can't. Packet filtering in general. Packet filtering devices look at some part of the packet, typically in the headers. Such things as source and destination IP numbers, source and destination TCP or UDP ports, for example, are all things that we might be interested in looking at, with the idea that we're going to make a decision to pass the packet through or not based on a set of rules that we have developed, and we often call this a rule base. And we will be writing these rules for our routers and our firewalls based on the business needs of our company. Now, think about this. I've had people get confused on this before. What else can you do with a port scanner? Well, I'm pretty much of the opinion that if an attacker is using some tool against you, you might as well learn how to use that tool yourself, because there's some things it can probably tell you. In the case of a port scanner, you should scan your own network to find out services and applications running on your computers that you may not know about. Microsoft is really bad about this, turning on services that you don't really need. So it's good to port scan your own computers and turn off things you don't need. You can also use a scanner to test the configuration of a packet filtering router or a firewall. You need something to create the packets that we're going to try to get through the router and the firewall. These packet scanners are very good at this. They'll make a packet with the send flag set, and they'll send it, and if they get back, depending on what they get back, they'll tell you whether the port's open or closed. So these using port scanners to test a packet filtering router or a firewall is a very good thing. Now, the reason I want to point this out to you is, in the past I've had some issues with students really understanding why we're using various ones of these utilities. So I'm going to concentrate on this. For example, from time to time when we're doing our port scanning, we're going to run probably Wireshark to look at the packets ourselves, just to get a familiarity with what they look like. You don't have to have Wireshark to run the port scanner. Typically, if I ask you to use Wireshark, it's just because I want you to see something. It doesn't really usually have any effect on the tool or the other tool you're using, or even the process that you're doing on the computers. It's just something that makes it real easy for you to see what's going on. So make a little note that to really listen when I'm explaining to you what we're doing with these tools, so you get you pick up the finer points of what the tools are doing for you and how you can and need to be using them.